Do you know that building smarter, reliable, and more efficient AI agents just got a lot easier? Welcome to the world of LangGraph. In today's video, we are going to discuss LangGraph and build a very efficient AI agent. We are on the React framework, not the React framework that you would be thinking in terms of your development. Rather, the React framework here corresponds to a very popular term used in the agents, such as reason and act. So it is a combination of reasoning and then acting upon. I'll quickly show you how the overall visualization for the agent would look like, and then we'll move forward what LangGraph actually does and how we can efficiently go ahead and make use of line graphs. So if you look at this particular snippet here, what we are trying to do is here we have an LLM, which is an AI agent, and we have user, which is the human agent. Now, an agent basically works based on the interaction between an AI agent and a user agent or a human agent to make results much more reliable to fulfill certain tasks that require human in the loop. Now, here we shall be supplying a code file, we shall be supplying a script, a code script to the LLM, which it will analyze. And upon analysis, it will help us with some observations that it found with respect to the code and also help us uh, determine what is the language of this code or are there any other associations, whether there are any errors in this code or not. Now, based on this, the user will give a feedback whether the observations that is generated by the LLM, how relevant are how relevant are these observations? Is there anything additional that the user would like the LLM to do, or just continue forward with the process, or just continue forward with the execution to go ahead and recommend the best possible code scenario given the input snippet? If there are any errors, how to fix those errors? If there are any changes that makes the code efficient, so what are those changes? Okay, so I'll take you through an example input and output that we have just processed so that you get further clarity as to what we are trying to build here. So here the code review assistant basically requires an input, which is the code input. Then it will use an LLM to analyze the code and generate observations. Based on the observations, it will ask the user or human agent to provide a feedback, which comprises the process of human in the loop. Now, with the human's feedback human's feedback that it receives, it will further go ahead and generate its own recommendations, combining its earlier observations and the user feedback. So this completes a loop, or this completes a cycle between an AI agent and a human agent to fulfill the task of code review assistant. Now, as I mentioned, I'll quickly take you through the example input and output that we have processed. Okay, so here, if you look at it, we have provided a system message for our agent, right? So our system message says that you are an expert AI agent that understands code flows. As an AI agent, your task is to first understand what programming language the code is in. If you're not familiar with a given programming language, let the user know about it. Think through and analyze the code for any error based on the programming language. Ask the user for feedback and wait. And the complete flow that it needs to follow is there should be an input code snippet, there should be a thought, understanding what programming language the code is in, analyzing the code for any potential errors. Feedback, this is the feedback that will be received by the human agent. So here we need to share our observations about the code or our feedback for the observations made by the LLM or AI agent, basis of which the LLM will further go ahead and act, combining the observations and the feedback to generate the final recommendations. So here we have supplied the message, or basically the code script here. This code script is something like this. I'll show you what this code script is in a while. We have already put it out in a variable above. Basis of this particular code snippet, the LLM generates the observations. The code snippet provided is written in Python, which is correct. There are few errors in the code. In the main function, variable y is assigned a string value 20 instead of an integer. This is something that is erroneous, that is present as part of the code that we have supplied. Okay. The result of the calculate sum function is an integer, but when trying to concatenate it with a string in the print statement, it will cause a type error.
the variable I is used outside the loop. Accessing minus 3 will result in index error. So all the errors that we basically had 4 errors in this particular script that we supplied, and it was able to capture all those 4 errors very well. Now, basis of which it is giving certain recommendations that we can do this, we can change the variable y, we can convert the result of calculate sum to a string, we can avoid using variable I outside the loop and ensure that the index used is within the range. Now with this, it is asking us that what is our feedback or what the human wants to do next, where in what direction it would like to go forward. So the human says, I would like to concatenate two numbers instead of summing them up. So while the observations made by this is good, but the human has changed his mind and now is asking the LLM to concatenate the two numbers instead of the original function of calculating sum. So the LLM now goes ahead, and I will not show you the complete output, but I'll just show you a snippet here. The LLM further recommends that we can create an additional function called as calculate concatenate that essentially converts the integer numbers that we receive into a string and then concatenate them, returning the concatenated string. So this is the main function, and this is the calculate concatenate. It has removed the rest of the components because the user has clearly mentioned that his or her objective is to simply concatenate two numbers and not anything else, right? So this is how you can build very powerful AI agents, bring in human in the loop, something which is very relevant in the industry when you're going for production ready code, when you're deploying AI agents. A human in the loop enhances the performance of your agents multifold. So with this approach of React, reasoning and acting, first reason out, then take an action, we are now going to delve deeper into LangGraph, which essentially takes the complexities of LangChain, right? You would have a question that sort of, I already know about LangChain. We already built various AI agents using LangChain. I'll attach some of the links in the I button above. But what it is so different about LangGraph? So one of the primary things is, while in LangChain, you did not have much flexibility or you did not have much control over the flow of information between the different tasks that the agent was carrying out. Here, because of the graphical nature of the LangGraph, for each step or each subtask that the LLM executes, you have much better control, you have much better flexibility in terms of the output it is generating, and therefore gives you much more reliable results. For instance, for the system that we developed, here is the graph that we have put forward. Instead of putting it in a complete cycle, I have rather used a linear graph here to keep things simple for the sake of your understanding. You can very well go ahead and create backlinks to formulate a loop. So we have code input, we have an input node, we have an analysis node, we have a feedback node, and a recommendation node. So, and everything starts with a start node and ends at an end node. Essentially, code input is our starting node and recommendation is our ending node. We'll go deeper, right? Just hold on for a while and make sure to watch the video till the end so that you follow the complete approach that LangGraph follows and how you too can go ahead and build much more efficient AI agents. And if you're new to the channel, make sure to subscribe and hit that bell icon so that the algorithm knows that we are back in the game and help spread the message loud and clear to more and more interested in generative AI people. Now coming back.
Now, the first things first, we shall now go ahead and look at the requirements.txt file wherein we have put forth all the libraries that we are going to use in building this AI agent using LangGraph. So for this we require NumPy, LangChain, LangChain OpenAI, LangGraph, and Python.env. Right? So all these packages you're already familiar with except LangGraph, which is essentially the package used for building LangGraph. Right? Now, towards importing various of these packages, so we are importing annotated from typing, typedict from typing extensions, langgraph.graph import stategraph, langgraph.graph.message import add messages, LangChain OpenAI, chat OpenAI, LangChain core messages, human message, system message, AI message. So these are just to represent the various types of messages that we are passing and receiving as output. Chat OpenAI is used for the LLM purpose. You can very well go ahead and experiment with Hugging Face based APIs. I have already extensively covered Hugging Face in my earlier videos. I'll attach the links in the I button above. Additionally, we have also looked at how to build some of the AI agents using LangChain. Again, check them out in the I link as well as in the description below. Now we are going to import our API key from the .env file. I'm not going to show you the .env file, but you know how we can go ahead and place our API key in the .env file and then import it using load.env. Here I'm creating an LLM using Chat OpenAI with the model GPT 3.5 Turbo. I'm setting a temperature of 0.3. You can play around with this temperature parameter as well as use any other text completion or models available within OpenAI. Right? If you are building a multimodal application, multimodal agent, then you can choose the ape model accordingly. Right? Now, one of the most primary requirements or one of the most primary things to understand with respect to LangGraph is that for each of the nodes here are designated to fulfill a particular subtask for the entire application that we are building. For instance, here for code review assistant, the first node here is used specifically for collecting the input or getting the code input from the user, right? So now in this regard, there could be two things. One, wherein you just let the flow of information go from one way to the other, from one node to the other, which is the stateless mode, in which you do not preserve the information generated in the previous node all across in the entire graph. However, if you would like to preserve the information that you generated in the earlier nodes or in the earlier tasks to be preserved towards the end of your entire application, you would require a stateful graph. So here, because we want to preserve the code input that we supplied, because we want to preserve the observations and recommendations, we are going to use a state-based LangGraph. Okay, so for that, we have to first define the state. For us, the state here is a dictionary type, is basically we are creating a type dict, and this basically comprise of a variable or attribute named messages, which is of the list type and calls the function add messages. Add messages essentially adds the output of the previous node to our chain of messages. Okay, it's nothing but just a list wherein you are appending the messages or the results that you get in your previous node outputs. Okay. Just follow the construct and you're good to go, right? Next thing, we have to build a graph builder. Essentially, we are defining what our graph would look like. So here we are calling this state graph from LangGraph and passing this state object or class state, right? So this will essentially help me define the structure of or basically the nature of my graph, whether it's a stateful graph or a stateless graph. Okay, now here I do have the prompt template that I have used for the system prompt. Okay, we already saw this system prompt when we were discussing about this code review assistant and setting you with the flow. You can basically go ahead, copy this particular prompt, right? You could basically go ahead and play with this prompt and modify it according to your own AI agent, right? Now with this, what we are going to next do is we are going to define the various nodes. Okay, so first we just created a dummy function which does nothing but accepts input from the user. So this input is basically the code input in the first node and also the feedback that we are awaiting after the execution of the third node. Okay, so and the first node that we have defined is also named as input node. For each of the nodes that we are defining, there is one essential parameter which is the state, because this is a stateful graph, so we have to pass in each state. So this basically preserves the information that was available before executing this node, and it will append the output of this particular node to the same state, thereby preserving the entire information in a particular state object. Okay, so we therefore pass a state object. If you additionally require multiple inputs to be passed, you can use something known as config. I'm not going into the details because that would simply take things in a different track. I'll provide the link in the description, you can check it out. So now using this state, what we are essentially doing, you have to do nothing, you just pass this state and then you return the message. And because we have already specified that we want to use the function known as add messages, which is an inbuilt function in LangGraph, it will automatically append any output generated from this node to the same state message. Okay, We are also defining the second our second node, which is known as agent. Again, we are passing the state. Here we are basically calling an LLM. So this is an LLM invocation. So we have two distinct nodes, and we are going to utilize these two nodes to generate our 4-step graph. Okay. So one is the human feedback, which is the input node. Let's see, here we are accepting the user input by calling this function. The other is the AI agent, which invokes the LLM. Okay. Now we go ahead and add the different components to our graph. So using this graph builder, we add the node, we name the node that we want to add, and we use the exact node from here. Similarly, we add node analysis, we add node feedback. If you look at it, both the code input and feedback uses the same input node, right? Thereby causing a cycle, right? Implicit cycle. And then the recommendation is again using agent. While I have provided you with the linear structure for the graph, but essentially we are reutilizing the same node, and therefore it goes back to the earlier node there, right? We now define the edges. We define the edge between code input and analysis and feedback, then feedback and recommendation. You could also you can create actual loops within the graph that okay. You can go ahead and add backlinks to your graph such that it creates an actual cycles there, right? We have to then specify our entry point and finish point for the graph. Here the entry point is code input and output point or finish point is recommendation. Once you generate this, your graph is now ready at a particular object ID. Next you have to do is compile the graph. So first is you define the state variable or the state class for your graph. Next up, you define the nodes for the graph. We're just following step by step, right? State, then nodes. Now you added these nodes to your graph, and then the fourth stage comes in. You compile your graph so that it is ready for execution, right? After compiling, what we can do, I just want to showcase it visually to you how our graph looks like, right? How the different ages that we have added looks like. So this is a sample code snippet that you can use to just display your graph on screen. This is how our graph looks like, and this is really fantastic and amazing, I would say. You can make it very extensive, you can add multiple branches to it, you can play around and do a hell lot of things there. Now, let us now follow the final step, which is the execution, right? Here in execution, there are a couple of things that you need to pay close attention to. So make sure you give your full attention and understand what are the different things that we are taking care of now. As I mentioned that we would have a sample code that we are going to use as input. This is a sample code that I have supplied. It has one function calculate sum, which essentially takes in two inputs A and B and returns a sum. Then we have a function def main, which takes nothing but two variables. Here you see the variable y is a string, whereas variable x is an integer, and it tries to calculate the sum for these two, right? I have also created a for loop statement where I am printing I within this for loop and as well as outside this for loop. Okay. Then I have a list here. Then for this particular list, I'm trying to index something which is out of order. So we have multiple errors in this particular sample code snippet. And for the purpose to help you understand, I have purposefully placed some of these errors. Okay. You can use this help function just to look at the various API references for the different functionalities there. Now we are going to go ahead and define our initial state because we have to essentially define the system message for our LLM. So in order to define that system message for the LLM, we are using an initial state that actually comprises of the system message. So I have created initial state. I am creating of type state. The messages I have set as a list, which is a system message, just with one element system message. And I'm using the prompt that I generated above, right? Now, the invocation becomes very interesting here, right? If you look at this invocation, what I'm essentially doing, I'm calling graph.invoke, passing my initial state and setting my stream mode as updates. There are multiple stream modes, right? There is a default stream mode known as values. You can set it as updates, you can check it, set it to debug and others. Now, one of the challenges when directly invoking this graph in this manner is it will follow the complete execution, and then only then you will be able to see any output, right? So if you go ahead and execute this, it will ask you for the inputs 2 times, and then finally it will generate all the possible outputs. I'll show you how the outputs would look like. Okay, so this is how the output would look like, right? This is the same output that we saw at the very start of the video as to how we are generating the output here, right? However, if you would want to make use of real-time processing for your graphs, which is most likely to happen in your AI agent case, you would want inputs to come in real time, and you would also like to see the outputs right on the screen as they are executing. So for that very purpose, we use something known as graph.stream, right? So I'll show you how that happens, right? So here, instead of calling graph.invoke, I'm calling graph.stream, right? So here I'm calling graph.stream, and I'm passing the initial state as I just did in graph.invoke. One of the advantages is it just creates a runnable object. It doesn't execute anything. It creates a runnable object. Now, every time you go ahead and call the different nodes in this particular event, it is only then going to execute that particular node considering the previous state output. Okay, it will preserve the state. It will go ahead and execute that node in the sequence that you would like to have it. Okay, so this is how it makes it different. You would have the outputs here, the same output, but the presentation becomes a lot different. So if you are building something, say you want a real-time processing, you want to plug it with some API call or something, then graph.stream is a much better option there because it helps you execute in real time. Okay, so now go ahead and let me know, what do you think about this video? Do you like this or such videos and would like me to present more of such videos in the future? If you like this, then certainly give it a thumbs up. Let me know your thoughts in the comments. See you in the next lecture. Have a nice day. Bye bye. Jai Hind.